Hey everyone, my name is Thomas, and by the ending of this video, you'll be able to do things like this, where you'll be able to run a direct agent that's hosted on Agent Core, as well as run it locally, because I also want to support both local development as well as in the cloud. So without further ado, let's go ahead and get started. So the proof is in the pudding. I firstly want to showcase the logs on AWS. This is one of the Deep Agent runs that I executed where I just had it create a sample.md file. Nothing crazy. I just wanted to demonstrate that it could actually write to a specific file path. You'll even see down here where it writes to that file. So let's go ahead and get started with some of the source code here. To be specific, the serverless Deep Agent will be on my GitHub, so please feel free to click the link in the description if you just want to peruse this yourself. But this is more of a high level of what this repo really contains. Like my other video where I talked about a serverless agent, this one is a serverless Deep Agent, and I copied a lot of the primitive structure that I had there. For example, I'm using Firefly as my LSP. I am using Poe the Poet as my runner. This allows me to execute commands like lint, format, and build. I am using Docker Compose as well as Docker containers to house this app because you have to actually upload it to Agent Core, which they only support containers right now. And then I also am packaging this little script underneath scripts just to showcase how to invoke it, just so we can have this local feedback. And you'll see here the arguments passed into the main function. So let's go ahead and explore here how I'm doing this. So if I click on infrastructure as code, you'll notice here that there is an app. For those that aren't familiar with the CDK, I'm not going to go into depth, but this is how you effectively will create a CloudFormation stack. And within that stack are the contained resources. And in this case, I am not using Amazon Agent Core starter kit. Instead, I am using the agent runtime alpha package here. We need to have some way to deploy this reliably. So if we look here, I create a deep agent artifact, and this just resolves the Docker image. Then I create memory. So yes, in this demo, I'm going to be showcasing a conversation with multi-turns. And you can even ask it a follow-up question or even something about the files, and it'll still be there in this ephemeral environment. I then create the agent runtime. I also feed it some environment variables, and I did hardcode here, Claude Sonnet 4.5. You do need some sort of decent model here, and ideally, like I like to use Anthropic models for tool calling. I also did some permissioning here. For example, I gave it all access to foundational models as well as all inference profiles. You don't have to do this. You can absolutely be more permissive or more specific on the permissions if you want. Here, I gave it access to CloudWatch logs, nothing crazy there. And then I use the nifty convenience methods of grant read long-term memory, which we're actually not using, but grant read short-term memory, that's for the conversation history. And then I'm granting write to the runtime for the memory. And for convenience, I use CFN output to showcase the runtime name as well as the memory ID, because you will need to update a .env file that will include your region, your memory ID, and the model. And that memory ID will come off of the stack. All right, so let's dive into the main.py. Very boilerplate, very quick and dirty. I didn't really go into depth here or do anything spicy. I really just have an app.entry point. Unfortunately, user ID has to be sourced from the payload for LangGraph. I don't really know of another way around this at the moment, because even if you pass in the argument of user ID or Agent Core runtime user ID, you can't actually see it and there's no visibility to it. Even this context that has headers within it, you can't see it. It's not exposed. It's actually used behind the scenes by Agent Core runtime. And if you don't know what I'm talking about, don't worry about it. Point is, the user ID needs to be passed in via a parameter inside of the JSON body. The session, however, is actually fulfilled by the service of Agent Core. And whenever I say that, it's if I'm passing a session to it, which in this case I'm enforcing it, or I go to the default. Then we also set up our configurable here. If you're not as familiar with the LangChain setup, just know that whenever you construct a deep agent, or really an agent in any way, they have this idea of a runnable config, and that is a LangGraph primitive. And this is what really behind the scenes will do checkpointing. So every single time a tool is called and resolved, it'll do a checkpoint. And this is very key for the messages back and forth with a human. We then grab the user message from the input. We then invoke the agent. I did not stream the output here, but you could have very well easily done this using a generator. But point is, I just grab the latest message and then output the content blocks. And just to showcase that this thing is working and doing the tool calls necessary, I also iterate through the messages and then pretty print them using the logger.info. And then finally, I just return the content of the latest message, those content blocks, as well as the session ID back to the user so it can be continued. So if we scroll up here, you'll notice that it's just 4 key variables here. We have the logger, which I just initialized just out of best practice. I then initialize the settings. This just helps grab the environment variables. Nothing crazy. I just like using Pydantic settings since I use Pydantic validation in the majority of my Python apps. I use Bedrock Agent Core app. This is mandatory to get that app.entry point, and this is just a part of the Bedrock Agent Core library. And then I am using the create deep agent from the DeepAgents library. I did a little bit further of an in-depth look on what a deep agent is and how it works. And I also dived into this repository. So if you want to see that video, the link will be added here. But point is, I pass in the model and then I add the Agent Core memory saver. This is what interacts with that memory component that we provisioned inside of the infrastructure as code. And really what this allows us to do is store conversation history. And of course, on the back end, what's going on is that AWS maintains this, or at least they're partnered with LangChain to support this. And the idea is that this configurable here with thread ID, actor ID, that is used in the backend to store it. I also threw in user ID here because this is standard for other types of monitoring libraries. So I just added there just in case. But just know that user ID is technically not necessary for this example. Just thread ID and actor ID are required for Agent Core memory. All right, so with all that said, if I head on over to my AWS account, I click on runtime, I do see the deep agent has been provisioned. You see I've iterated on this a little bit here. I'm on version 14. There's also memory associated with this. So this memory ID is where both long-term and short-term memory can be saved. But for the purposes of this example, it's really just that short-term, which is more conversation history. You can get into the long-term stuff when you start saving user preferences across chats. That's a little bit more advanced than I'm trying to go for this. And then just know that these runtime environments are ephemeral, so it will actually have a VM provisioned for you with a file system, and you can keep continuing with this file system. It's pretty neat. It's easy to get started on this with Amazon Bedrock Agent Core. So finally, let's go ahead and just run this thing. So I did grab the Agent Core Bedrock runtime ARN, and I am passing in a session. Actually, you know what? Just in case I've used this session before, I'll just spoof it and put a 10 at the end. I'm giving it a user ID, just something bogus, Thomas, and I'm asking it just to create a simplistic sample MD file and output the contents. I'm hoping to trigger the right amount of tools here. So let's go ahead and invoke this. And now we see, perfect, I've successfully read the file back. The contents match exactly what was written. And it says here, line number 1, main heading, sample markdown file, and then it gives us a breakdown here, and it gives us that session. So for funsies, I'm going to go ahead and ask it just to prove that this conversation did have history. Wait, what did I just ask you before? Just to see if it gives us, hey, well, you asked me, create a sample MD file and output the contents. And sure enough, you asked me to create a sample, then read the output contents. That's perfect. And they even iterated with a little bit extra and mentioned that, hey, we did do your task. But yeah, we can continue this conversation. You can even reread the files back because they are saved temporarily inside of those VMs. And like I mentioned, I do favor that local development feedback, especially because I don't want to have to keep uploading to Agent Core runtime directly. So you can run this Docker container. And here you'll see that I pass in the header to at least give the session ID. And I have just kind of spoofed a UUID here. And I'm giving that exact same prompt of create a sample MD file, then read the file and output it to me. And I am giving myself as the user. So hopefully this will hit the deep agent. It will give back something, some sort of file that we can see. And then I'm going to continue the conversation, just simply ask it, wait, what did I just ask you? Just to see if the memory is being persisted. Great. So I see there's some stuff there, some code snippets. So let's go ahead and say, wait, what did I just ask you? So perfect. You see here, you asked me to create a sample MD file. So that's exactly what we would expect here. And then we see the session ID is the same across both of these turns of the conversation. So this is what I would expect using the lane graph checkpointing system in addition to the Agent Core memory. Also just want to comment an additional note here. So at first I was confused on the positioning of Amazon Bedrock Agent Core, especially because Amazon Bedrock has yet another feature called agents. In fact, let me bring that up right here. So you'll see they have this huge blue banner up here. It says deploy and operate AI agents at scale. Easily export your existing Bedrock agent config. So it looks like they may probably deprecate this service in the future, or at least keep it on life support for a little bit longer. But this was their first abstraction at trying to create an agent that would orchestrate tools through an OpenAI or OpenAPI spec that would then target certain Lambda functions. It was honestly tough to use and not something I ever advocated for. But this Agent Core service is certainly a step in the correct direction, and there's still more work they can do, but at the end of the day, they're just giving you those foundational building blocks to just enable you to go faster. Because when I work with enterprises, the last thing they want to hear is, let's add yet another vendor into our stack, for example, to spin up ephemeral environments and use file systems, when you can just say, hey, let's use Amazon Bedrock Agent Core. All the primitive structures are already there for your liking and for your taking. And so at the end of the day, Amazon Bedrock Agent Core is nothing more than, think of like an ECS abstraction where they'll house the container for you, which is really just an API invocation endpoint. They also have that memory, which is what I just showcased you in this tutorial. And these memories can be both short-term and long-term. In addition, they have really cool features like these built-in tools like browser and code interpreter. While once again, I didn't showcase it in this tutorial, these are pivotal features that really separate them apart from other infrastructures that don't necessarily have this, or at least not off the shelf. And then lastly, it looks like they are going to explore this observability and evaluation space, which is absolutely a must-have for agentic experiences. Because honestly, building the agent is dirt easy. So many frameworks out there enable you to do this really quick, but at the end of the day, you're only as good as your evals. So to see that these observability and evaluations are trying to be pushed into some sort of direction that's cohesive within this ecosystem is also a great sign. So hopefully you guys understand Amazon Bedrock Agent Core, how you can house a deep agent, specifically using LangChain's Deep Agent, because they have the deep agent with the harness already capable and built in for you at your disposal. You don't really have to think about the prompts. And guess what? They're going to iterate over time. So that would be my go-to for a deep agent on Amazon Bedrock Agent Core, especially for an enterprise. So if you guys did enjoy this video, please drop a like, please drop a subscription, and let me know if you want to see more content like this. Thank you so much for watching. See you in the next one.